Good morning. Again we are going to continue our topic in the subject physics. In the previous classes we have started nuclear physics and I have explained what is the rate of decay dN by dt proportional to n, or n is equal to n naught e power minus lambda t. So the curve is called the exponential curve, so that the answer may be converted into logarithm form into exponential form. A curve as shown in the figure is got. If you draw a curve between the number of atoms in the y-axis, time taken in the x-axis. So if number of atoms becomes 0, it never comes to x-axis. So it will take infinite time to come. So to avoid, to escape from the answer, the logarithm curve converted into exponential curve. But we can able to find out what is the time taken to reduce exactly half of the original value. That is called half-life. This is also n naught by 4, n naught by 8, like that, 2 times t, 3 times t, like that. So from this graph we can able to find out the value of half-life and mean life. We know n is equal to n naught e power minus lambda t. So just now I explained about what is half-life. Half-life is defined as it is the time taken to reduce exactly half of its original value is called half-life. So total number of atoms n naught, if time taken to reduce exactly half of its original value, that means n naught by 2, the time taken is called half-life, capital T off. Therefore, when T become half-life, n become n naught by 2. Substitute that n naught by 2 is equal to n naught e power minus lambda T off. So n naught getting cancels and reciprocally, that is e power minus plus lambda T off is equal to 2. Or taking logarithm, therefore lambda T off is equal to log to the base e2, or T off is equal to log to the base e2 divided by lambda. This is the formula for half-life, but we know the exponential value lies in between 2 and 3. Therefore, if log to the base 10, e converted into log to the base 10, that should be multiplied by 2.303 into log to the base 10 2 by lambda. We know log to the base 10 to 0.3010 and multiply everything, we can get T of equal to 0.6931 by lambda. So this is the formula for half-life. T of equal to 0.6931 by lambda. This is the half-life. From which also we can able to find out the mean life also. What is mean life? The mean life is called average life. The average life, symbol tau. The mean life is always equal to 1 by lambda. We know T of equal to 0.6931 by lambda or 0.6931 tau. This is a relation between the half-life and mean life. Once we know this, we can able to find out that is a thing we have to understand it. So from Rutherford Soddy law, we can able to find out the number of atoms present in a particular time. It can able to find out. If time taken to reduce exactly half of its original value is called half-life. So this is given in this chart. N is equal to n naught e power minus lambda t. This curve is called exponential curve. This exponential curve never comes to touch t. So the curve is like that. So kindly modify this curve. The curve is like that. It never touches. This is the correct one. Activity Similarly, n is equal to n naught e power minus lambda t, A is equal to lambda n. This dn by dt is called activity. The rate of decay is called activity. dn by dt is called A. Therefore, A is equal to minus we have to add it, lambda into n, or lambda into n naught e power minus lambda t, or A is equal to a naught e power minus lambda t, or A by a naught is equal to e power minus lambda t. Like that, n by n naught is equal to e power minus lambda t. The radiation measure can be used by the unit Curie or becquerel, because becquerel noted the radioactivity. He named the unit of radioactivity in terms of Rontgen. You know Rontgen, the previous class, discovery of X-ray. So when he did the experiment on X-ray, suddenly, accidentally, he found the radioactivity. So that in order to honor Rontgen, he named the radiation measure unit Rontgen. Generally, unit Curie. 1 Curie is equal to 3.7 into 10 power 10 disintegration per second. Also becquerel, which is 1 disintegration per second. 3.7 into 10 power 10 disintegration per second is called 1 Curie. 1 becquerel is nothing but 1 disintegration per second. Just now we have seen half-life, n by n naught. This is an important formula, n by n naught is equal to half to the power of n. What is n is equal to n naught e power minus lambda t. So n by n naught is equal to half to the power of n. So this n by n naught or a by n naught, whatever may be the thing, n by n naught or a by a naught. We know n by n naught is equal to e power minus lambda t. If t become t power half, that is half to the power of n. What is n? Number of half lives. After n half lives, t is equal to n into t power half. That is a thing we have to understand it. After n half lives, the time taken become n times t into half. T half is called time taken to reduce half of its original value. If there are n half lives are there, n into t and half, that will give the time taken after n half lives. Time taken what to find out? First we have to find out the value of n. N can be compared with the formula. You can able to find out the value of n. This formula is very important for your entrance examination is concerned. Just like that, n by n naught is equal to half to the power of n. Just like that, a by a naught also a to the power of n. Just to have seen the mean life, the reciprocal of decay constant will give mean life. The nuclear reactions. The nuclear reaction A plus small a is equal to B plus small b plus Q. Q energy release. It is possible to convert one element into another by bombarding its nuclei with some lighter nuclei. Bombarding its nuclei with some lighter nuclei. This is called generally nuclear reaction. The higher atomic element may be converted into some other element by the emission of alpha or beta. So here we can take any lighter element that may not be radioactive. For example, 7N14, nitrogen is an ordinary element. It is bombarded with a helium atom. That means alpha particle. They become A2O17 plus 1H1. That reaction is called nuclear reaction. That means here nitrogen converted into oxygen with the emission of a proton. Discovery of neutron. So I already told you that inside the small area called nucleus, in which it is constituent with the proton and the neutron. These proton and the neutrons are called nucleons. Neutron actually discovered by the scientist Henry, who is discovered Chadwick. Chadwick in the year 1932 discovered neutron, Chadwick. So we know beryllium atom, lighter element, beryllium, 4 beryllium 9 is bombarded with alpha particle. Just like our nitrogen bombarded with alpha particle, beryllium, 4 beryllium 9 bombarded with alpha particle, beryllium become carbon 6C12 with the emission of additional particle 0N1. At first they thought some additional particle comes from the nucleus. There may be some rays due to alpha particle or beta particle like that. But the energy of that new particle may not matches with that. Therefore, there is another particle inside the nucleus along with the proton that is called neutral particle, hence named as neutron. This was actually given by the scientist Chadwick in the year 1932. How the neutron was invented? When beryllium converted into carbon with the bombardment of alpha particle, the new particle comes is called neutron. Artificial radioactivity. What is a natural radioactivity? Just now we have seen. Natural radioactivity, the spontaneous emission of alpha, beta and gamma particle, that is called natural radioactivity. The artificial radioactivity, I already told you that some lighter element may not radioactive. We can make it as radioactive by the bombardment of any charged particle. For example, aluminium. Aluminium is not radioactive. 13 aluminium 27. It is bombarded with the alpha particle through He4. This aluminium becomes phosphorus. 15 phosphorus 30 actually star. This phosphorus 30 become radioactive with the emission of neutron. Aluminium 27 bombarded with the helium, phosphorus 30 is produced. 15 phosphorus 30 gives silicon. 14 silicon with the emission of electron with the additional particle neutrino. This is also possible by the bombardment of alpha particle. We can convert aluminium into phosphorus, again phosphorus into stable silicon. Phosphorus 30 decays to silicon 30 by emitting a positron and a neutrino. Half-life of phosphorus, everyone knows, 2.55 minutes. What is the half-life of phosphorus 30? Phosphorus 30 half-life is 2.55 minutes. Uses of radioisotope, not radius. This is called radioisotope. What are the uses of radioisotope? What is radioisotope? We can take isotope of any element that is kept inside a particular aluminum vessel, that may be kept inside a nuclear reactor for several weeks. And each and every reaction, neutron comes. This neutron again reacts. There is a chain reaction coming out. Because of multiple bombardment of neutron, the nuclear obtained is called radioisotopes. The radioisotope, a small quantity of radioisotope is mixed with the stable isotope of same element, and tracing its course, many information can be obtained. These radioisotopes are very much useful in medicine, agriculture and industry. So industry also, we can find some flaw inside the metal or anything that can be identified by using radioisotope. In medicine also, radioisotope is used in the treatment of cancer, radiotherapy. And agriculture also, so what is in how fertilizers may be given for the plant, that may be identified using radioisotope, phosphorus 30, we know. Like that, any radioisotope can be utilized for industry also. Nuclear fission. Nuclear fission is also important thing. The nuclear fission, the heavy atomic element split up into constant element is called nuclear fission. It can be done by itself. But taking any heavy atomic element, split up into consonant element. That is called nuclear fission. Fission means division. For example, uranium, 92 uranium-235. This uranium-235 bombarded with neutron that become uranium-236. That is an important thing. So uranium-236. 92 uranium-236 when uranium-235 bombarded with neutron. This uranium-236 divided into barium and krypton. Barium, 56 barium and 36 krypton. As far as mass number is concerned, 141 and 92. 56 plus 36, 92. So, Z tallied. As far as A is concerned, 141 plus 92, we are getting only 233. There are 3 neutron is balanced. That means it becomes emission of 3 neutron, not 30. This 3 comes here. 3, 0, N1. It is not like that, 30. That is 3, 0, N1. 0, N1 is called neutron with the emission of uranium split up into barium and krypton due to the balance. How the neutron comes, there are three neutrons coming out. These 3 neutrons again bombarded, that become 6 neutron, like that the multiples of neutrons coming out, that stimulate the reaction continuously. That reaction is called chain reaction. Each and every reaction, large amount of energy is released, nearly 200 MeV energy is released. If the chain reaction actually in the atom bomb, therefore atom bomb works under the principle of nuclear fission. What they did, there is a uranium-236 with the bombardment of neutron, it split up into consonant element, barium and krypton, emission of neutron, the neutron again bombarded the reaction continuously. Those reaction is called chain reaction. And each and every reaction, large amount of energy is released. This energy always for destructive purpose. So scientists thought, if large amount of energy released in the each and every nuclear fission, why it is utilized for destructive purpose? Instead of this energy may be utilized for destructive purpose, that energy may be utilized for constructive purpose also. So if we are controlling the chain reaction, we can use it for constructive purpose. That actually happening. So where it is possible to control the chain reaction, that place is called nuclear reactor. Nuclear reactor is one in which the chain reaction may be controlled. This controlled chain reaction, the limited energy may be utilized for constructive purpose. We know Baba Atomic Research Center, Homi Baba, everything was a close friend of Jawaharlal Nehru, and did a foundation in Baba Atomic Research Center, where the first reactor was launched. There, the chain reaction is controlled, large amount of energy is released, that energy is utilized for constructive purpose. In Kalpakam, that is also power reactors, Rana Pratap Sagar, all many reactors are there, Zarlina, Purnima, Cyrus, like that, all the reactors are there. The power reactors are one in which it can create its fuel by itself. Usually it's a uranium-236 as a fuel or thorium. Whatever maybe we can use as a fuel, but any nuclear reactor create or produce its fuel by itself are called power reactor. We are having Kalpakam. In Kalpakam, nowadays in the Kulothungan, all are new reactors giving much energy for us for constructive purposes. The chain reaction of nuclear reactor, nuclear fusion. So nuclear fission, we know heavy atomic element split up into constituent element is called nuclear fission. Like that, to lighter element, also to fuse together become a heavier one. That is also possible. How? The heavy atomic element split up into constant element. Like that, a lighter element, two lighter elements may combine or fuse together. We can form a new bigger element. In this process also, large amount of energy is released. Such a system is called nuclear fusion. For example, 1H1, 4 proton combine to form helium-4 with the emission of electron or positron, 2 plus 1 E0. That is, we have to put like that. 1 E0, there are 2. Therefore, 2 into 1, 2. 2 plus 2, 4. 1 into 4, 4. The numerator 4, that is 4 into 0, that is 4. 4 plus 0. Here also large amount of energy is released. Nearly 25 MeV energy is released. The nuclear fusion, due to nuclear fusion only, we are getting large amount of energy from the sun. So, solar energy are due to nuclear fusion. So, we know sun is a nearest star. We know sun is also a star. In star and the sun, we have to understand the proton cycle or carbon-nitrogen cycle. One proton combined to form helium, again helium release one proton, automatically they become proton. That is called proton-proton cycle. In all other nucleus, carbon-nitrogen cycle may be there, carbon converted into nitrogen, again nitrogen converted to carbon. So this is a chain reaction repeatedly done so that sun never loses energy. So when carbon dies, it become a nitrogen. Nitrogen become carbon, like that. Proton become helium. Helium become proton, like that. The cycle comes so that each and every reaction, large amount of energy is released. That energy is called solar energy. So the solar energy never loses its energy. We are thinking like that. The sun is slowly lost its power, and one fine morning, the entire power of the sun may be lost. That is wrong conception. So according to physics, according to nuclear fusion, since it is a cycle, never it lost its energy. So hydrogen bomb. Hydrogen bomb was on the principle of nuclear fusion. Atom bomb was on the principle of nuclear fission. Solar energy due to nuclear fission. Cosmic rays also there. What is a cosmic rays? The cosmic rays, we know, the rays which are coming from upper atmosphere is called cosmic rays. These rays are actually given by Russian scientists. So Russian never use astronomy, astro. They are using astrophysics as cosmos region. The particles are coming from, these rays are coming from upper atmosphere or cosmos region called cosmic rays. The cosmic ray shower and the cosmic ray coming out, the cosmic ray photon divided into electron, positron pair. So that is called pair production, or sometimes the electron positron combine to form cosmic ray photon, that is called annihilation. Again it divides into two, so it is called cosmic ray shower. The intensity of cosmic ray when it approaches the upper atmosphere increases, when it comes down the intensity going on decreases. And also in the geographic area, when you go to the equator, there is a deviation of cosmic rays. That is called latitude effect and the altitude effect of cosmic rays. And what is called the elementary particle? So we are thinking that proton, electron and neutron inside the nucleus. Among that there are so many particles are there. At first meson, pi meson, like that. So many elementary particles was invented. Nearly 4 elementary particles, proton, electron, neutron and photon. Subsequently more than 200 were discovered. Positron, neutrino, antineutrino, meson, mu meson, pi meson, like that, pion, like that. So many pions, n pions. So that so many pi meson. Pi meson is called a pion. That is called mu meson. That is called mu meson, muson. Like that, so many particles are coming. That more than 32, nearly 200 elementary particles, neutrino, like that. They are grouping according to their mass and their properties. Then matters and antimatter. So like that, matter and antimatter. We know electron. Electron with a negative charge is called electron. There is a particle, antiparticle also there. That is called electron with a positive charge. That is called anti-electron. Like that, proton with a negative charge is also called antiproton, positron. Like that, so many particles are there. So like that, why there is a matter, antimatter will be there. That was actually energy particle. There is an antiparticle of electron, positron. When a particle and its antiparticle come together, they annihilate, annihilate each other. Is both, that is electron positron pair, is both vanish and the missing masses appears in the form of 2 gamma ray photons. That is a photon. So annihilate also. What is pair production? The cosmic ray photon divided into 2 electron positron pair. Again, electron positron pair combined to form annihilation. So that is the cosmic ray photon of energy gamma ray. If a high energy photon comes close to the nucleus of an atom, gets converted into an electron positron pair. That is called pair production. Just now I have told you that. Why I am telling that? The antimatter, like that. So we are having the world. There must be anti-world. We are imagining like that. They may advance in the science. They send so many inventive measure for us. Possible. Maybe. We cannot say it is sure, or we cannot say it may not possible. If it is a world, there must be an anti-world also possible. That is a thing scientists are thinking like that. So, these are the things we have to understand. So many items here. So, antiparticle and the cosmic ray particle, cosmic ray showers, all are very, very smaller thing. We have to understand it. So, you can solve some problems in nuclear physics. This completes your nuclear physics. I already told you that it is a small topic and loaded with the definitions and the other thing. The first problem, the half-life of radon is 3.8 days. After how many days will only 1/12 of radon sample be left over? This is the first problem. The half-life of radon, 3.8 days. After how many days will only 1/12 of radon sample be left over? So for this, the solution, we know, just know that lambda is equal to 0.693 divided by Tr. So how it comes? We know half-life period, T of is equal to 0.6931 by lambda. From which lambda is equal to, I have calculated. So here, as per the problem, 0.693 divided by half-life is 3.8 days given. That is called day power minus 1. I already told you that the time taken T is equal to 2.303 by lambda into log to the base 10 n naught by n. So I already told you that T is equal to half to the power of n. So total time taken. The total time taken means 2.303 half-life into log to the base 10 n naught by n. That is the time taken, e power minus lambda t. Therefore, n is equal to n naught e power minus lambda t, from which I have used this formula. What is, we know n is equal to n naught e power minus lambda t, or n by n naught is equal to e power minus lambda t. So minus, the time increases. So taking log on both sides, simply lambda t is equal to log n by n naught. Therefore t is equal to 1 by lambda into this formula. So here multiply by 2.303 for log to the base 10. Simply substitute this 2.303 divided by lambda 0.693 divided by 3.8 into log to the base 10 20. What is that? 20 disintegration 20. On simplification 16.45 days. This is the answer for this problem. Log to the base 10 20. 20 30 10 1 bar 3010. Substitute this everything, we can able to find out. What is the concept of this? Once we know the lambda, from which the total time taken can be calculated. The second problem is a very important thing. Calculate the amount of 84 phosphorus 210. It is an protoaction required to provide a source of alpha particle of 5 millicurie strength. The half-life is 138 days. Calculate the amount of 84. Calculate the amount of 84 PO 210 required to provide a source of alpha particle of 5 millicurie. Then this problem can be calculated by using the formula activity. Both are same. N by N naught, A by N naught. Activity is nothing but dN by dt is called activity. A is equal to lambda into N, dN by dt. That is equal to 0.693 divided by half into N. We know T half is equal to 0.69 by lambda, from which lambda can be calculated. Therefore, N is equal to A T power of divided by 0.693. So, from which N can be calculated, the value of N. N is equal to A into 0.693 lambda divided by that value. So, this value can be substituted here. Therefore, activity 5 into 3.7 into 10 power 7 into 24 into 300, that will be converted into days. Days may be converted into second. Whole divided by 0.693. On simplification, 3.13 into 10 power 15. This is the value of N. But our question is, what is the amount of PO 210 required? Amount of PO 210 required. 210 into 3.183 into 10 power 15 divided by 6.022 into 10 power 23. That is a capital N value, Avogadro number, nearly 1.11 into 10 power minus 6 gram. 1.11 10 power minus 6 gram. So these are the problem relating activity and the thing. But usually the problem asked in this way only. This is a very important problem. This is also repeated problem for us. The half-life of radium is 1600 years. The fraction of a sample, fraction FRA, the fraction of a sample of radium that would remain undecayed after 6400 years is, this is a repeated problem. So from it I have to find out the number of half-lives. Number of half-lives 6400 divided by 1600, that is equal to 4. Number of half-lives. We know remaining undecayed. What is undecayed atom remaining? We know half to the power of n, that is half to the power of 4, that is 1 by 16 is the answer. How the 1 by 16 comes? If I take the total atom become 1, so when time increases, number of atom decreases, therefore 1 by 16 atoms remaining after 4 half-lives. That is the thing we have to understand it. How the 4 half-lives comes? 6400 by 16. That is the thing we have to understand. Otherwise we can put initially 1 atom, after half-life 1 by 2, second half-life 1 by 4, third half-life 1 by 8, fourth half-life 1 by 16. Like that also we can find out. The last problem, the radioactive material X1 and X2 have decay constant 10 lambda and lambda. This is also interesting problem and also last problem. If initially they have the same number of nuclei, then the ratio of the number of nuclei X1 to the X2 will be 1 by E after a time. So this problem, how can you solve this? We know the first one, N1 is equal to N0 e power minus E lambda t, isn't it? E lambda t. N2 is equal to N0 e power minus lambda t. Because the problem is given, the radioactive material X1 and S2 decay constant 10 lambda and lambda. So here instead of that 10 lambda t, so e power minus 10 lambda t, here e power minus lambda t. Because the problem given as X1 has half-life 10 lambda, it is simply lambda. Therefore N1 by N2, this N0 getting cancels. E power minus 9 lambda t. Because dividing, this goes in the numerator, plus lambda t, e power 10 lambda t minus lambda t. Simply the problem given n by n2 is nothing but e power minus 1, that is equal to e power minus lambda t. Therefore comparing these two equations, the t must be 1 by 9 lambda. If t become 1 by 9 lambda, the thing cancels, e power minus 1. So what is the time taken? The time taken is 1 by 9 lambda. This is important problem. So among the 4 or 5 problem, this 1 by 2 power n or a by n is equal to whole power n. This is the problem may be asked. So kindly make use of these problems, very repeated only. So here also interesting problem. So you have to think it of yourself, and also as far as the nuclear physics is concerned, the statement questions are very, very important and also very minimum problem like that. We need not worry about this massive calculation. In our problem only simply, I am giving this, the concept alone we have to take into consideration. So next chapter we will see in the next class. Thank you.